Now that we're familiar with the idea of a variable identifier, let's think about the value that's stored in the variable. In order for our program to save information, we have to assign a data value to a named memory location. And we do that with a special symbol, which we call the assignment operator. The assignment operator looks like the equal sign, and we already saw it in the examples we typed in earlier. Whenever we created our variable pi, we said pi, and we used the assignment operator to assign the value 3.1415 to that named memory location. When we created uname, we used the assignment operator to store the data value University of Mary Washington to our variable called uname. And when we created our variable maximum, we used the assignment operator, the equal sign, to assign the value 10 to that named memory location. Now let's notice a few things here. Whenever you create your variable, you have to put the identifier on the left-hand side of the equal sign, the assignment operator, and you have to put the data value on the right-hand side. Let's see how Python reacts if we don't follow that norm. Let me start a new shell. So suppose that I create that variable pi, but instead of typing in pi equals 3.1415, I type in 3.1415 equals pi. Now that's completely normal in math class, and it doesn't really matter which order you type things in a traditional math or algebra class, but it matters a lot to Python. If you type in the information in the opposite order, Python will produce an error message that says it can't assign this variable pi to this literal value 3.1415. Literal is a special word that we use in computer science to mean any kind of value that's literally the value. It's something that can't change. So this value 3.1415, that's a literal value. It's something that's not a variable in our program. It's the actual piece of data that we're trying to store. Let's do another example. Suppose we said Karen equals name. Again, something like that's completely fine in an algebra class, but it's not going to work at all in Python. Again, it tells us I can't assign this variable name to a literal value, Karen. So it's really important to put your identifier on the left-hand side and your literal value on the right-hand side. That keeps Python happy, and it understands what you're trying to communicate to the computer. Another thing you might have noticed is that sometimes when we're creating these data values, we use double quotes, and sometimes we don't. If we're creating a variable to store a numeric value, like maximum storing the data value 10, or pi storing the data value 3.1415, we don't use double quotes. Python doesn't use double quotes to delimit any kind of numeric data values. But if you look at the example where we stored text information, things like my name or the university's name, Python needs to have the double quotes around the text that represents that data value so that it knows where it stops and starts. So whether the text is several words that are connected together to have a particular meaning, like the University of Mary Washington, or whether the text value is just a single word, like a name, you need to have the double quotes that surround that group of text so that the computer knows to interpret that as one data value. So just as a rule of thumb in general, if you're storing numeric values, you should not use the double quotes, but if you're storing text information, you should use the double quotes. Let's do a couple examples just to see what happens if we forget to use the double quotes. Suppose we type in University of Mary Washington, no double quotes. Python will give us an error message. Notice this time it gives us the error message on the character right after the space. That's where Python detected, hey, I don't really understand what you're talking about on the rest of this line. I'm a little confused, not sure what this means. Python is not smart enough to realize that that's all one data value and that you were thinking all of those words were connected to each other. Python will also give you an error message if you are just storing a single word and you forget the double quotes, like name assignment operator Karen. And it tells us the name Karen's not defined. That's because it's thinking of it as another identifier name. It's not realizing that that was the literal text value that we wanted to assign to the variable called name. In order to signify that this is a text value to store in memory, a literal value, we have to enclose it in double quotes. Now, an important property of variables is that over time, they can store information and allow that information to change in value. In fact, that's why we call variables variables, because the data that they store is allowed to vary. Whenever the value in a variable changes, the computer cannot remember anything about the past data values. And this is kind of interesting to us because we're not used to things operating in this way. Let's look at an example. Suppose that we are storing a variable called maximum and that we assign it the value 10 using our assignment operator. If we print out the value of maximum, Python will tell us, hey, you're storing the value 10. Now suppose that later on we change the value of maximum so it's 5. When we print out maximum, Python has completely forgotten about the old data value 10 and replaced it with the new data value 5. If you're thinking about our ice cube tray, it's kind of like we took a Post-it note, wrote the value 10 on it, and put it into one of those squares and labeled it maximum. And then later on we decided, I don't want the value 10 in there anymore. So we threw that piece of Post-it note away, and now we've created a new Post-it note and stuck it into that same memory location. Now we're storing the value 5 inside that memory space. This is, again, it's kind of unusual to us in this day and age. We're so spoiled and used to there being a undo button in our word processor, a back button on our web browser, and just a myriad of ways to kind of undo our last step. And so it's really unusual for us to think about the fact that that's not part of the built-in behavior when we're writing software. Whenever we replace a value, it's completely replaced and the computer has forgotten all about the old value. Now, that's certainly not to say that you can't store both the number 5 and the number 10 in a software program. It's just saying that if you want to do that and you want to keep track of both values simultaneously, you have to put them into different named storage locations. You can't call them both maximum. Let's look at a little example to make sure you understand. Look at this example program down here. There's 4 lines. Have uname equals Mary Washington College, then print uname, and then we assign the value University of Mary Washington to uname, and then print uname. What do you think will happen? Let's test it out. Oops. In my class notes, I'm missing a double quote there. You should definitely add that in. In fact, I'll run it once without that just so you can see the error that happens. If there's no double quote there, it'll produce a syntax error. It'll say, I'm scanning the string literal. That means the part that's in the double quotes. And I got to EOL, that stands for end of line. So it's telling me I got to the end of the line. I was expecting there to be a double quote to close out this string literal, but I didn't see one. Again, you fix that by including the double quote at the end. All right, so we created the variable uname equals Mary Washington College, and if we print that out, of course, it's going to print Mary Washington College, the information that we stored in that memory location. And then if we update the value that's stored there, to make it equal to the University of Mary Washington, and then we print uname. Now it's going to forget all about Mary Washington College and print out the new name, University of Mary Washington.